Hi, in this video we'll be discussing angles of elevation and depression using sine, cosine, and tangent. So before we start these story problems, I want to give us a little overview of what angle of elevation and depression means. If you are standing on the ground, here you be, and then here's the Cahill, right? And your friend's up here. You have your line of vision just straight ahead, and then you're also looking at your buddy. From this eye line right there, and then the angle looking up to your friend is the angle of elevation. Okay, now your friend, he would be the same way. He can look out, but then he's also looking down. So in this case, here's his angle of depression. So depending on which way you're oriented, we're talking about angle of elevation or angle of depression. Let's go ahead and start. And you'll actually find that I like to kind of draw the triangle to give us a better idea of what we're looking at. Search and rescue is responding to a hiker who has fallen in Zion National Park. The helicopter sees the individual at an angle of depression of 44 degrees. So let's figure out what we've got going on there. We've got somebody who's fallen. Help. I can't get up. And here's the helicopter pilot. Now, if you were looking straight ahead, he or she, there's that line of sight. But then they've got to look down at our fallen hiker. And it told us that that angle of depression is 44 degrees. Now, what does it want to know? Let's see. The helicopter is 20 feet above the victim. All right. That means this distance right here is how far? 20 feet. And how far away are they from the victim to the nearest foot? So we're going to be rounding. We want to know this distance right here. Here's my angle. X is definitely the hypotenuse. 20 would be the opposite side. I've got hypotenuse and opposite, so katoa, that means I'll be using sine. Sine of 44 equals opposite over hypotenuse. Times both sides by x. And then I need to divide by sine of 44. So x will equal, let me grab the calculator here, 20 divided by the sine of 44. Oops, I put 77. That's not going to help me. 20 divided by sine of 44. Now, I really recommend when you're doing these problems with me, grab your calculator while I'm doing it and make sure that you're getting the same answer as me. Now, I got 28.79, but it also said round to the nearest foot. So that would be 29 feet. That helicopter is 29 feet away from that victim. Okay. Let's go on. Nathan is standing on the top of Angel's Landing. He sees another hiker on the trail below. All right, here's hiker number 2 with his walking stick and backpack. Let's see. His location is 120 feet from the hiker, and the angle of depression So how do we figure out angle of depression? Oh yeah, we look straight ahead and we look down. And the angle of depression is 53 degrees. How much elevation does the hiker have left to go? So we're looking at this part right here. Let's see, from 53, I have opposite, and this is my hypotenuse. That's another sine problem, isn't it? Sine of 53 equals opposite over hypotenuse. This one's a little friendlier. All I need to do is times both sides by 120. 120 times the sine of 53. And I get 95.8 feet. It didn't say it around, but the last one said to round to the nearest foot. So I'm going to go ahead and do the same thing. That hiker's got 96 feet in elevation left to go. And our last problem. I think this is a two-step problem if I remember correctly. So let's take a second and figure out what it means. A soccer player kicks the ball 30 feet from an 8-foot goal. Well, let's have our goal be right here. Here's our goal. All right. If the ball travels at an angle toward the center of the goal, will the player make the point? So he kicks it 30 feet from. This distance here is 30. Our goal is 8 feet high, and the ball has a projection of a 13-degree angle. And what we're wanting to know is how high does that ball go? So this 8-foot mark right here is a little misleading. We want to know how far that ball's going to go over that 30-foot distance. So we've got a side here. Here's our right angle. So this is our hypotenuse, which means I've got side and side, opposite and adjacent. I'm going to be doing tangent here. Tangent of 13 degrees equals opposite. We're wanting to know how high that ball goes. Is it going to go above 8 feet or below 8 feet? So that's our unknown over adjacent, which is 30. Times both sides by 30. 30 tangent of 13. 6.9, or roughly, that ball's going to go about 7 feet high over those 30 feet. Will it fit inside the goal? Absolutely. This is a big yes. 7 is less than 8, right? All right, good luck with the homework.